Okay, so here is a problem wherein you're given a reaction nickel plus copper 2 plus producing nickel 2 plus and copper 2 plus. You're asked to calculate the cell potential, the Gibbs free energy, and chemical equilibrium for this reaction. And you're also asked to calculate the potential of this cell when the nickel 2 plus is 0.01 molar and copper 2 plus is 1.0 molar. So if you're going to look at this reaction, so the first thing for you to determine is which is the one that is happening in the cathode and which one is the one happening in the anode. So if you're going to look at this, you should have a reduction potential and then look at the reduction potential of each of the species that are involved here. So if you're going to look at the reduction potential for nickel, it's negative 0.25. For the copper, it is 0.34. So based on this one, okay, copper is the one that undergo reduction, so that's the anode, and nickel is the one that undergo oxidation, so that's the cathode. So for the cell potential, E cathode minus E anode. So you replace the value that you have there, okay? 0.34 minus 0.25. So this is equals to 0.59 volts. Now, the next question that we have here is for the Gibbs free energy. So delta G is just equals to negative NF cell potential. So N, based on the reaction here, so you could say a 2 plus for both of the charges here. So most likely you have 2 electrons, okay? And then you multiply it with the Faraday constant. So we can put it around 96,500. And then the cell potential coming from the previous calculation. So it's going to give you a number that is around 113,870 joules, or around 113 kilojoules. So it's a negative, so which means it's spontaneously react. Okay. So the next thing that we're going to do is to determine the K. So we could say delta G is just equals to negative RT ln K, and then we rearrange ourselves. So delta G is over negative RT, that is equals to your ln of K. So we're going to use the value that we have here. Okay. So negative 113,870 joules over negative 8.314 times 298, okay, to give you the ln of K. So from this, you're going to get a value that is around 45.96 equals to ln of K. Now, to get the K, so you just get the E raised to the 45.96, and K is equals to this value, which is so high, which means it favors the forward reaction. Okay. Now, for the last part, we're going to use the so-called Nernst equation, okay, wherein we have E equals to cell potential minus 0.0257 over N, okay, and we could ln of the products, which in this case is the nickel, over the copper 2 plus. So we just use the reaction here. So we know this one is equals to what? 0.59, and then this is equals to 2. So ln there, given the value, so 0.01 over 1.0. Okay. So if we're going to go here, we get 0.59, and you're going to get around 0.059 something. So you will get around 0.65 volts as the answer to the cell potential when you change the concentration of the reagents involved.